Right, we've got to find the matrix of this. So the matrix that we're looking for, M, acts on my source points to give me image points. You'll notice I use this setting up of an equation just all the time doing this linear transformation stuff. It's possible to do it other ways, but I really like just this. If I start with this standard equation, it works everything all the time. Right, I've got to find my matrix. I'm going to choose 2 points that I'm going to do. I'm not going to choose 0, 0, because that's no use at all. It doesn't tell me anything. But I will choose 2 of the other points, and I think I'll choose maybe B and D. So the point B is at. You only want 2 because I'm going to keep it myself a nice square matrices rather than 3 points. Now, point B is at -3, 1. Negative root 3, 1. And that's point B. And point D, which is the other one I'm going to use, is -1 root 3. Remembering to write the points vertically every time. Now, that would correspond to B, so that's B and D. I'm going to go to B dash and D dash. You've got to go to corresponding points, of course, or it would fall apart. B dash is 1, -1. 1, -1. And D dash is 0, -2. Okay, we just have to find what that matrix is. Well, it's just a matter of using matrix arithmetic now. So here we go. M then equals 1, -1, 0, -2, multiplied by -√3, 1, -1, √3. Inverse. Inverse on the right, remember, because we have to keep the order. Order is critical with matrices, so I must multiply on the right by the inverse. M this time equals, well, that's 1, -1, 0, -2. We have to work out, we get 1 over the determinant. Now the determinant is -3, -1. That's +1. Okay, that's AD minus BC. And then we have, right, swap the positions, so you get √3, -√3, and make the other 2 go negative, so you get 1, -1. There we go, that's me doing the inverse part of that. As a point, just to sidetrack just for a little bit, this equation here, I think you can put it into your calculator and solve that, which of course is a lovely thing, so you know what your answer is going to be. Anyway, we will carry on. Right, M equals, I'll be careful here. You can so easily put it, you're copying these things down just to miss out a minus when you go from one line to the other, so I'm trying to be real careful and get that right. I'm going to get -1/2 here, because that'll give me -2 on the bottom. And I'm going to get √3, 1, -1, -√3 there. Any number can go to the front, and because it will only complicate things, I'll leave that number till last, and I'll deal with that at the end. Then I'm going to get 1, 0, -1, -2. That's a 0, not a 6. √3, -1, 1, -√3. And finally, let's do the multiplying out. This has taken a long time, isn't it? Right. Into, I'm going to get √3. I'm going to get 1. I'm going to get -√3 plus 2. And I'm going to get -1 plus 2√3. That's not looking very pretty. Multiply through by my -1/2. And that's really very, very ugly. Now let's make that multiply through by the minus sign. So I get 2 over. Yep, and multiply that. That's going to give me 1 minus 2. Oh, well, that is just a horrible sort of equation, isn't it? Right. If that's my linear transformation. Oh. Okay, well, I'm assuming that that's right. I might just make sure that I'm just going to check and cheat and look at the answers. Before I go on to the next part, I want to make sure I've got the first bit right. What have I got here? Well, I'm in agreement with the textbook so far, so I'm going to keep going with this. That's the first bit done then. That is the matrix. That is your transformation matrix. So that's the linear transformation then. So that means that M takes x, y, 2. Negative root 3 on 2x, negative half y. Root 3 minus 2 over 2 x plus 1 minus 2. Okay, that's the linear transformation. Now we've got to describe its components, and that's a tricky thing to ask. I'll just leave that there now. No, I'll just pause and do a bit of thinking. Oh no, I don't want to start a new video. Okay, I'll keep going. Here we are. Here's my original picture. I don't think if you just looked at the equations you would be able to tell. I think the picture's required to try and work out what's going on here. Now you can see I was thinking in my head that there's a rotation, and I think that probably is a rotation. And it's give you that, and then there's some sort of dilation or perhaps a shear or something else is going on after that. I think I'll try and work out first of all what the rotation is, and then I'll see what I'm left with, and I should be able to work out the second part. Actually, no, I'm going to stop this recording here because this second part is actually quite a difficult question, so let me just stop this recording here.